had that other balloon here, and it is under a lot of pressure also. It is nice and full. Now, if I were to squeeze this too tight, it would pop, okay? Or if I poked a tiny hole in it, it would pop, and it would make a loud pop, and that gas would escape very, very quickly. If I didn't have it tied and I blew it up and I let go, you would know what would happen. That balloon would just go zipping everywhere because that gas escapes very, very quickly. Okay, so you know that those gases like to move very, very fast. Now, if you poke a balloon, if you put too much pressure on it, it's eventually going to pop. Okay, and you've probably done that before. You've probably popped a balloon. It's under a lot of pressure. If I squeeze it too much, that gas says you can't squeeze me anymore, and it just bursts right through. Okay, and I'm not going to pop my balloon. But pressure is how much force you're putting on it. So when we talk about pressure, it's how much force, and you know, it's like a squeeze. So we're squeezing. If you squeeze that balloon too much, it's going to pop. Okay. Now, Boyle's law is a law you're going to read about this week. And it says that if you put a lot of pressure on an object, if you squeeze it, that pressure is increased, meaning I put more pressure on something, the volume is going to decrease. So if you think about that, if I squeeze my balloon really hard, my balloon gets smaller. See the end? Look at that. I squeeze it, the end gets smaller. Okay, so here we have a couple containers. We see we put the lid down. If we put the lid down on this container, it squishes my gas down. So my volume decreases. It was taking up this amount of space. When I put the pressure, now it's taking up this amount of space. So it doesn't take up as much space. Now, Charles' law says if I increase the temperature, the volume would increase. Now, I know we're getting close to the end, so just you guys listen. If I decrease the temperature, the volume's going to decrease. And that's what we saw with our balloon. If I increase the temperature, or if I decrease the temperature, I put it outside where it's cold, my balloon shrunk. My volume decreased. It didn't look like I had as much gas in it. But as soon as I brought it in, those gas molecules started moving really, really fast, and it filled up the balloon again. And we heard it cracking as it started to come back to, you know, its full shape. And it filled up as fast as it could because those gas molecules are moving so fast that they're hitting the outside of the container, keeping it full. When I cooled it down, the gas molecules did not move so fast. Now, they didn't get so cold that they became a liquid, but they moved down a lot slower. And because they moved down slower, the outside of the balloon shrunk.